Hello students. Hello and welcome to this video. In this video, we will solve question number 81 to 90 of binomial theorems and expansions. The link to download the PDF will be in description, as well as at the end I will show you how you can download and maintain an updated copy of the book. And I will also show you the question answer website which I have created for you. So without further ado, let's get started. Question 81 says that C0 times CR plus C1 times CR plus 1 plus so on up to Cn minus R times Cn is equal to 2n factorial upon n plus R factorial times n minus R factorial. So here we take the expansion of 1 plus x to the power n and x plus 1 to the power n. So we just reverse the terms. And then we multiply, we get 1 plus x to the power 2n C0, and then the expansions are written here. Okay. Now coefficient of x to the power n plus r in right hand side would be C0 CR, this C should be capital, C1 CR plus 1 and so on up to Cn minus R Cn, and on left hand side it would be 2n Cn plus r, that is 2n factorial upon n plus r factorial times n minus r factorial. Question 82 says that we have to find C0, we have to prove that C0 square plus C1 square plus C2 square up to Cn square is equal to 2n factorial upon n factorial times n factorial. So we write 1 plus x to the power 2n as C0 plus C1x plus C2x square up to Cn xn, and right hand side would be C0 x to the power n plus C1 x to the power x n minus 1 and up to Cn. So we equate the coefficient of x to the power n, we get C0 square plus C1 square up to Cn square is equal to 2n Cn, that is 2n factorial upon n factorial times n factorial. Question 83 says that we have to prove that C1 upon C0 plus 2 times C2 upon C1 plus 3 times C3 upon C2 and so on up to n times Cn upon n minus 1 is equal to n times n plus 1 by 2. So here Rx term is R times NCR upon NCR minus 1, that is n minus R plus 1. So we sum the value from T1 to Tn. So T1 would be n and T2 would be n minus R, n minus 1, T3 would be n minus 2 and Tn would be n1. So sum of this we know from arithmetic progression is equal to n times n plus 1 upon 2. Question 84 says that we have to prove that 1 plus C1 plus C2 up to Cn whole square is equal to 1 plus 2n C1 plus 2n C2 up to 2n C2n. So we take 1 plus x to the power n and we square that, we get C0 plus C1x plus C2x up to Cnxn whole square. So this becomes 1 plus and 1 plus x to the power 2n is equal to 2n C0 plus 2n C1 into x plus 2n C2 into x square. Now we put x is equal to 1 to find that 1 plus C1 plus C2 plus up to Cn whole square is equal to 1 plus 2n C1 plus 2n C2 up to 2n C2n. Question 85 says that 1 plus C1 plus C2 up to Cn whole to the power 5 is equal to 1 plus 5n C1 plus 5n C2 up to 5n C5n. So proceeding like previous problem, we raise to the power 5, that is 1 plus xn to the power 5, we get C0 plus C1x plus C2x square up to Cnxn to the power 5, and 1 plus x to the power 5n is 5n C0 plus 5n C1 into x plus 5n C2 times x square up to 5n C5n times x to the power 5n. Again we put x is equal to 1 to see that 1 plus C1 plus C2 up to Cn whole to the power 5 is equal to 1 plus 5n C1 plus 5n C2 is equal to up to 5n C5n are equal. Question 86 says that we have to prove that C0 plus C5 C1 plus 9 C2 up to 4n plus 1 Cn is equal to 2n plus 1 times 2 to the power n. So left hand side we can write as 4 times 0 C0 plus 4 times 1 C1 plus 4 times 2 C2 up to 4n Cn plus C0 plus C1 plus C2 up to Cn. We know that C0 plus C1 plus C2 up to Cn is equal to 2 to the power n. Now C1 plus 2 C2 plus 3 C3 up to n Cn, we consider that series, and the rth term is r times ncr is equal to n times n minus 1 cr minus 1. And we find the sum by taking the sum of this term from r is equal to 1 to n, which we already have deduced in earlier problems, which is equal to n times 2 to the power n minus 1. Now we multiply this by 4, we get this series, which is the part of the left hand side over here. This is equal to 2n times 2 to the power n. And we add this and we add this, okay? And we get the desired result. Excuse me. And we get the desired result. Now question 87 says that we have to prove that 1 minus 1 plus x times c1 plus 1 plus 2x times c2 up to 1 plus 3x times c3 is equal to 0. So we have to prove this, and what we do is we take, let me see, this should be 1 minus c1 plus c2 minus c3. This is definitely wrong. And this would be x times c1 minus 2c2 plus 3c3 and so on. So this has been proven earlier that both would be 0. So that's how we prove this. There is massive typing mistake in this one, it seems. Yep, this should be C0 minus C1 plus C2 minus C1. That way we have to write, which will be equal to 1 minus 1 to the power n. And this we have proven earlier. Question 88 says that we have to prove that 3 times C1 plus 7 times C2 plus 11 times C3 up to 4n minus 1 times Cn is equal to 2n minus 1 times 2 to the power n plus 1. So we can write this as 4 times 0 times C0 plus 4 times 1 times C1 plus 4 times 2 times C2 up to 4n Cn minus C0 plus C1 plus C2 up to Cn. And this series we know that is equal to 2 to the power n. And this we have already evaluated earlier, which is equal to n to the power 2n minus 1. So multiplying by 4, we get 2n to the power 2n. 2n times 2 to the power n, and we add this series and we add this, rather we subtract this, we get 2n minus 1 to the power 2n. Question 89 says that we have to prove that C0 plus C2 upon 3 plus C4 upon 5 and so on is equal to 2 to the power n upon n plus 1. So here TR is 2, 4, okay, 2, 4, 6, that way, even terms are only there. So TR is equal to NC2R minus 2 upon 2R minus 1 is equal to n plus 1 C2R minus 1 upon n plus 1. So we sum this series from R is equal to 1. So it becomes 1 upon n plus 1 comes outside, n plus 1 C0 plus, this should be R is equal to 1, then it should be 1. This should be 1. This is not 0. Plus n plus 1 C3 plus n plus 1 C5, which is equal to 2 to the power n upon n plus 1. Question 90 says that we have to prove that NC0 times n plus 1 C1 plus NC1 plus n plus 1 C2 up to NCn times n plus 1 C n plus 1 is equal to 2n plus 1 factorial upon n plus 1 factorial n factorial. So we know that this expansion we have and this expansion we have, which we know we multiply and equate the coefficient of x to the power n plus 1, we get nc0 n plus 1 cn c1 plus nc1 times n plus 1 c2 and so on up to ncn times n plus 1 cn plus 1. That is equal to 2n plus 1 cn plus 1, which is equal to 2n plus 1 factorial upon n plus 1 factorial times n factorial. And with this, we come to the end of 90 problems. And now I will show you my website from where you can download the copy PDF of the book. So link 2, 3, and 4 will give you the PDF of algebra, trigonometry, and coordinate geometry respectively. When you download the book, do not forget to add this date to the PDF. They do not contain the date. Now I cannot put the date in the PDF because if I put the date in the link itself, then all existing links will become invalid. Also note that there are lots of typing mistakes in the books, so you need to be careful while reading them. Also, if you want to ask questions, then you can come to my website, kundika.astavakar.org, following the eighth link. The eighth link leads you to kundika.astavakar.org. You can make a login here to ask questions. Tags are there for you: algebra, calculus, coordinate geometry, mathematics, probability, and trigonometry. So make a login and ask questions, whichever you have for me, and I'll be most happy to answer your questions. And with this, I would like to end the video here, and we will meet again tomorrow with 10 more problems on binomial theorems and expansions. Thanks a lot for watching the video. Stay curious, keep learning, have a great day, and most importantly, enjoy.